Welcome to a new exercise. We continue the study of accelerated motion, and in this time we're going to use the only formula that does not involve time. So let's jump right in. A car moving at 10 meters per second is entering the highway where the traffic moves at 40 meters per second. Find the acceleration needed if there is only 100 meters available for the car to speed up safely. We start by looking at the quantities that are given in the exercise. We have the initial velocity. The car is moving at 10 meters per second. This car is entering the highway and the traffic is moving at 40 meters per second. So if you want the car to merge safely, we want this to be the final speed. So this is another way we know the final velocity of the car. So we know the initial velocity, final velocity. We also know the distance that the car has. So this is like the shoulder that the car has to merge properly into the highway. And we're being asked to find the acceleration. So we start by drawing our little cartoon. We have our x-axis, which we have seen many times. We call x equals 0. The origin of the coordinate system is the point where the car will start accelerating from 10 to 40 meters per second, and this safe distance we call it d. So we could have a cartoon here that is that there is a highway, and this is our highway where the traffic is moving in that direction, and our car comes here in this shoulder of the highway, and the shoulder ends at this point. This is the point D. So this is our car looking from the sky, and the car is accelerating here on the side of the highway so it can enter moving at the same speed of the traffic. So we know the final velocity is 40 meters per second. We know the initial velocity, which we usually call v0, and we know the distance. That is the cartoon of the situation. One very important thing to notice here: there is no information about time. There is no mention of time. There is no question related to time. Therefore, time has nothing to do in this exercise. That immediately is a clear signal that the formula that we have to use is the only formula of accelerated motion that doesn't involve time. So let me write that here. It says that the square of the final velocity is equal to the square of the initial velocity plus 2 times the acceleration times the distance. This is the formula that we have to use. It's in fact the only formula that doesn't involve time. And we notice that the final velocity, so the quantity on the left, we know. The first term on the right, we also know, is the initial velocity. We know the distance, because the maximum distance that we have available is this 100 meters, this quantity that we call d. Basically, d will go here. And a is a quantity that we are being asked to find. So let's solve this. Let's basically rewrite this equation, solving for a, which is the acceleration. For that, I will simply reverse right and left just for simplicity. So here, the only thing I'm doing here is I'm putting on the right what was on the left and vice versa. V square. So I will pass this initial velocity to the other side. This becomes v square minus v0 square. And now I divide on the two sides by 2x. So the acceleration is v square minus v0 square divided by 2x, which in our case is d. Now we just need to plug these numbers. The final velocity, we want it to be 40 meters per second. This is the idea of speeding up safely. The idea is that the speed is going to be the same as the one of the traffic. The initial velocity was 10 meters per second. So we have to take the square of that. And then we divide everything by 2 times the distance, which is 100 meters. In the numerator we have 40 square minus 10 square, close parentheses, divided by, again, in parentheses, I have 2 times 100, which gives me 7.5. 7.5. And the units, as I mentioned, since all the length units are in meter and the time units are in seconds, the unit of acceleration is meter per second square. And there we have it. The only reason I wanted to bring up this very simple exercise is a very simple way to identify which formula we have to use. In this case, there is no information about time, which means it's very, very likely that the formula that we have to use is this one. In this case, we knew the initial final velocities and we knew the distance, so finding the acceleration was quite trivial. So again, just keep this in mind because it can save you some valuable time in your exam, because sometimes it's not about just plugging the numbers, it's also about being able to identify which formula you have to use. And this is one of my personal recipes when it comes to exercises about accelerated motion.